Okay, so this is going to be part 2 about ellipses, where we're going to allow the center to move away from the origin. So similarly to the parabolas that we already looked at, you replace x with x minus h and replace y with y minus k. So that's nice that that's easy to remember because you already learned it for the parabolas. So the equation for the ellipse is going to look like x minus h squared over the a squared plus y minus k squared over the b squared, and the center is now going to be at hk. So the minus signs are part of the equation. And the rest of the ellipse, the focus points, the vertices, all shift with the center. If you go to the right 3 and up 4, all of the points go to the right 3 and up 4. Again, if the A number is bigger, the ellipse is bigger in the horizontal direction, and if the B number is bigger, the ellipse is bigger in the vertical direction. So to graph the ellipse, find the center, go plus or minus A in the x direction, plus or minus y, B in the y direction, and make dots. So the ones that are farthest away from the center are the vertices. And then that will tell you which line is the major axis, and you know the focus points have to go on the major axis. So let's look at an example. We're going to analyze this equation. So we need to find the center. So remembering that the minus is part of the equation, the center is going to be -4, -2. So that's where the center of our ellipse is going to be. So it's going to be at -4, -2. So here's my center. Now I look under the x term and I see a 9. So the square root of 9 is 3. So I need to go +3 and -3 from the center. So now I can see where 2 of the points on my ellipse are. And then I look under the y squared term and I see a 4. So that tells me I need to go up 2 and down 2 and get 2 more points on my ellipse. So now I can draw it and see what it looks like. And I can see that it's bigger in the horizontal direction. So the vertices are going to be these points that are the farthest away. And I can see from my graph that the points are -1, -2, and -1, 2, 3, 4, 5, 6, 7, -7, -2. And those are my 2 vertex points. Then remembering that c squared is the difference of the denominators. So c squared is 5. So that means c is plus or minus √5. So that's how far it is from the center to a focus point. So it's a little more than 2. A little more than 2. But we know how far that is because we can look at the coordinates of the center and say, let's see, you go to -4, and then you add √5 to go to the right, √5, and that's the x coordinate, and then the y coordinate is going to be -2. So that's going to be this focus point. And then I need to go to -4 and subtract √5 and stay at -2 for the y coordinate. So just as a double check, make sure the center, the vertices, and the focus points all have the same one of the coordinates. If your major axis is horizontal, they should all have the same y coordinate. If your major axis is vertical, they should all have the same y coordinate. So as with the parabola, you may need to complete the square before you get started. So let's look at this problem where I have 4x squared. I'm going to rearrange it so the 8x is by the 4x squared. Then I have plus 3y squared minus 6y equals 5. I'll be super careful when you're completing the square with some multiplier in the front. So you can either divide by 12 on both sides so that you don't have multipliers on the front. I think that's going to be harder because you'll have fractions. So I would factor out the 4 from the 4x squared and the 8x to give me x squared plus 2x. And I'd factor out the 3, and that'll give me y squared minus 2y. Now I haven't changed anything yet, so I'm still going to have a 5 on the other side. But now inside these parentheses, I need to complete the square. So I can see that I need to add a 1. But if I add a 1, inside those parentheses, how much have I really added? Oh, I've really added a 4 because of the 4 outside the parentheses. Then I have plus 3, and I need to add 1 inside this set of parentheses to complete this square, but I'm actually adding 3. So make sure you're really careful about how much are you actually adding when you complete the square there. So now I'm going to have 4 times x plus 1 quantity squared plus 3 times y minus 1 quantity squared equals 12. Now I am going to divide both sides by 12 because I need a 1 on the right to be in standard form. So I'm going to have x plus 1 quantity squared over 3 plus y minus 1 quantity squared over 4 equals 1. So I can see that this ellipse is going to be larger in the vertical direction, in the y direction, the way the y-axis goes. So I'm going to draw my ellipse by, look under the x direction, and I see a 3. So I need to go plus or minus root 3 in the x direction. So let's call that root 3. Then in the y direction, I need to go plus or minus 2. Whoops, I forgot about my center. So I need to start from the center. And that looks like it's going to be negative 1, 1. So let me get my little eraser out here. Get rid of these guys. There we go. So I need to start from the center at negative 1, 1. Here's my center. Then from the center, go plus or minus root 3. And in the y direction, plus or minus 2. So I can see how my ellipse goes. And I know in the x direction, I went root 3. So the center's at negative 1. And then I went plus root 3. And minus root 3. And in this case, when the ellipse is longer in the vertical direction, all the y coordinates better be the same. So negative, nope, I said that wrong. All the x coordinates should be the same. So these are the co-vertices that I'm finding. So instead, let's look at, well, let's finish this. Negative 1 plus root 3, comma, positive 1, and positive 1. These are going to be those co-vertice points that we use to help draw the ellipse. Then I go 2 in the positive y direction from the center. So I'm going to still be at x coordinate of negative 1, but now I'm going to be at 3. So that's one vertex. Then I'm going to be at x coordinate of negative 1 and go down 2 from the center, and I'll be at negative 1, negative 1. So those are my 2 vertex points. Then I know c squared is always the difference of the denominators. So that's 1, the difference of the denominators, and c is plus or minus 1. So that means the distance from the center to the focus is 1. So here's a focus point, and here's a focus point. So our focus points are going to be negative 1, 2, and negative 1, 0. And those are going to be our focus points. So the equation of the ellipse was this part right here. And then we had to graph the ellipse. So now we have one of the tricky problems again where they give you some bits of information and you have to figure out what's going on. So if your center's at 1, 2, you know you have x minus 1 squared over something plus y minus 2 squared over something. And we know our focus is at 1, 4. So let's see what this picture looks like. If the center's at 1, 2, and the focus is at 1, 4, Well, then we know that C, the distance from the center of the focus, is 2, so C squared equals 4. So we do know that the difference of the denominators is going to need to be 4. And then we also know there should be a larger number under the y direction, since this ellipse has the focus points lined up along a vertical axis with the center. So we also know that this ellipse contains the point 2, 2. So I have 1, 2, 1, 2. So this is a point on the ellipse, and it's right in line with the center. So that tells us in the x direction, we went 2 in the positive direction, and we must go 2 in the negative direction. So the number under x squared term has to be 4, 2 squared. Well, then we know whatever b squared is, b squared minus 4 has to equal 4, because that's what c squared is. So it looks like b squared equals 8. So our equation is x minus 1 squared over 4 plus y minus 2 squared over 8 equals 1. Okay, and then there's applied problems in the text. So I'm going to ask you to look there and figure out how to do the application problems, and promise you that there won't be a difficult one on the final exam. So let me know if you have any questions.